Good evening, everyone. Welcome to sixth live session for the course Functional and Conceptual Design from IIT Madras. My name is Neelarnab Dutta, and I'm a PMRF fellow and a PhD scholar from IIT Guwahati. So the agenda for this class is to help you with your week 6 assignments. The deadline is tomorrow, that is 7th September. Please make sure you submit your assignments on time. So since the nature of uh, the questions in the assignments are objective, so in this class I will cover some of the important concepts that will help you in solving those assignments. So here are some of the important concepts that we have learned in the last class. So first one is, we learned in the last class what is product specifications. So product specification is basically, we when we try to quantify the qualitative requirements of a user, we convert the user needs into specific product features or specifications. Okay. And the nature of product specification is quantitative, so it has a matrix and a value. For example, in the last class we talked about designing, identifying customer requirement for design of a classic bike. So one of the needs that we have identified was like comfort, comfort to ride. So one of the specs can be the seat cushion. Okay, but seat cushion is again something subject. So comfortable seat cushioning is again subjective, so we need to quantify this. So we need to make sure that we arrive at a right matrix. For example, it can be the width or the height of the cushion, or the density of the foam. So it can be height or the density of the foam, and we need to have some sort of value. For example, it can be, seat cushion can be like 50 centimeter. Okay, and similarly the density can be something around like 15 centimeter gram per centimeter cube. Okay, so this is how we convert the qualitative user requirements into specifications. So next thing what we learned in the last class was how to arrive at particular product specifications. So what we learned here is, like, first thing is like benchmarking customer requirements. So we have a set of needs. Okay, so what we do first, we rank these needs based on their importance, that has been derived from the contextual inquiry that we did during customer need identification phase. And then what we do is we gather information on customer reviews for various competitive products or companies. For example, company 1, company 2, company 3. So for example, if a particular need is comfort and company 1 is, for example, Royal Enfield, so you say, okay, 5 star. Then if it is a Honda, then it is, for example, 4 star. Then probably Bajaj, it is 3 star. So likewise, we gather all sort of benchmarking for various requirements, various needs. Okay, that's what is benchmarking. After that, what we do is we come up with the specification. That means the required matrix with the value. Okay, so against the needs, we come up with certain specifications. For example, as I told before, like comfort to ride can be like seat cushioning thickness, or it can be like a density of foam. Okay, likewise we can have another. This is like comfort. Another need can be like, easy to handle. Easy to handle. So that means a specification can be weight of the bike. So what we do in the second phase, we actually gather the values from the competitive products or companies. For example, what is a particular seat height for a company like Royal Enfield? For example, seat thickness for Royal Enfield is 15 centimeter. Similarly, for a company like Honda is 10 centimeter. Similarly, for Bajaj, it can be like, something like 13 centimeters. So likewise, for every particular specs, we gather the values. So next, what we do, we compare, like in stage, at the in the third level, as a third task, like where a particular company get a 5 star and what is their specification or the values. Okay, for example, if for comfort, Royal Enfield have a 5 star rating from customers, that will analyze so which are the needs or which are the specs that actually satisfy that particular need comfort. So we found here that seat thickness and density are actually satisfying the comfort. So we consider that is a value as the ideal value. So what we do in the stage 3 is we set the ideal value and the marginal value. Ideal value is basically what it should be, and marginal value is what is the range of how much it can be altered based on our design requirement. So for example, if seat height ideal is 15 centimeter, so we can say because of our larger engine, we can make it at least greater than 13 centimeter. So those at least, at max, all those things comes under marginal values. Okay, what we do after that, we reflect on the results. During this phase, we analyze what are the various specs that we need to consider so that we solve or we fulfill or satisfy the customer requirements. Okay, and there are a few methods how we do this. The fourth step, one important tool is quality function deployment. So in quality function deployment, we consider all our findings, 1 2 3, and then we try to map across a graphical representation called house of quality. So what is basically that? It is basically a graphical representation of all our findings. For example, we map the needs, then we have the importance against the specifications. So you can have different specifications, and this is the space which is called a relationship matrix, where actually we map or we check which particular specs are satisfying which particular need. Or similarly, we can also relate from this side, like how many needs are satisfied by a particular specification. For example, if we have if a particular specification like weight of the bike can be satisfied by many needs. If this particular feature actually satisfies can be satisfied various needs. For example, like easy to handle, then easy to transport, okay, and then uh, comfort. So you can check here, like a particular which are the specifications which actually satisfy multiple requirements. Similarly, we can also check like for easy to handle, what are different specifications that are satisfying this particular thing. So this is where we are actually analyzing the relationship between needs as well as specifications. Then we mapped these against the benchmarking what we did previously in one, like for particular need. So how much a particular company like Royal Enfield, Honda, okay, how much, you know benchmark we will provide based on the customer satisfaction or customer feedback. For example, these are the various ranking like 3 star for easy to transport, and for Honda you can say 4 star for easy to transport. Likewise, we do here the benchmarking. So this is the area where do we do benchmarking. Similarly, below we map the values, the specification values for all the three companies. So this is company C1, C2, C3, and for particular specification, for C1, what is the value? For example, if it is a weight, then 155 can be for Royal Enfield. For company like Honda, it can be like 135. Bajaj can be 120. So likewise, we map various specification values, and then we select a target value which can be ideal value or a marginal value. Okay. And by using this particular graphical representation, we can actually analyze what sort of specifications we need to consider. What should do we need to actually increase certain value, or we need to decrease certain value in order to meet the user requirements. So this is a single piece of tool where actually a lot of things can be analyzed before we arrive at a final set of product specification. Okay, so in today's class, I'll be talking about some of the other important concepts. So what we did in the last class, we actually reached from the customer needs to product specifications. Okay, okay, but we are still away from actually the concept. Okay, so now the question comes like what needs to be done in order to convert these specifications into concepts. Okay, okay, so for that we need to understand what are functions and what are constraints. Okay, let me give an example here. So these are the various requirements or needs that we came across, and accordingly we have identified certain features. For example, and the particular need 1 and 6, for example, easy to balance and easy to transport, can be satisfied by adjusting the weight of a vehicle. Okay. Similarly, height of a vehicle, this particular matrix can solve the user requirement of easy to balance, comfortable to ride, then easy to transport. Okay, so likewise we arrive at a particular set of matrices. Now we need to understand, like in order to convert these sort of matrices into final product features, we need to understand how many of them are actually product functions, and how many of them are actually constraints. So what is the difference? So let me give an example here. For example, a specification like height of a vehicle, okay, can be decided prior at the conceptual level. Okay, we can actually design the frame in such a way that the vehicle height does not go beyond this particular 120 mm. Okay, so this is something we can achieve through deciding on the height. So this is a function. Okay, because we can actually uh, by modifying the frame, we can actually come up with that particular height. Okay. Similarly, cushion thickness, we can actually achieve that by changing the foam design, or you can know by considering particular thickness of foam. So we can take that as function. Okay. Basically, function does not mean only something physically working, motorized. Function also means something that is functioning a certain uh, activity, certain required task. That's why we are considering these as functions, because we are able to uh, perform the change by changing certain parameters. Similarly, damping coefficient of spring, okay, we can actually consider the material as well as the particular design of the spring to arrive at this particular, you know, coefficient level. So this is again a function. However, there are certain matrices which actually we don't have a control. For example, if we say weight of a vehicle, okay, we cannot pre-decide this particular matrix, because there is no way we initially can fix a particular weight of a vehicle, because there are a lot of dependencies on various functional elements. What we can say that this is a constraint, that the weight should be maximum 180 kg, and we need to select different components or parts in order to meet this particular constraint. Okay, thumb sound can be decided, it can be worked on by working on the speaker or the the exhaust design. So this is again a functional, this is again a functions. Luggage capacity, yes, because this means, like for example, if you want to carry around 40 kg of luggage, that means you need to provide certain saddle stand or some sort of luggage carrying plate on top of the bike, and so design of this particular structure matters in order to carry this particular weight. So this again comes under function. Fewer parts, again fewer parts, we cannot consider that as a function. We can only say that is a constraint, because we do not have a control at the initial level, like how many parts, within how many parts we can actually design this particular concept classic bike. Okay, so we need to understand from our matrices, like what are the functions within those matrices and what are the constraints within those matrices. So is it clear? Okay. Okay, so out of constraints and the functions, which actually we have classified our matrices, like the specification matrices, we consider the functions as a way to move forward for our conceptual design. Okay, because constraints we consider as a checkpoint, like a checkpoint to make sure you choose particular material, you choose particular component in order to achieve this particular constraint. However, function we decide based on the requirements. So what is functional decomposition then? Okay, so what is functional decomposition is basically breaking down a higher level function into a smaller sub functions or intermediate sub functions. For example, if someone says like, okay, the higher level function is like comfort, okay, comfort, comfort to ride. Then probably a smaller level sub functions can be seat, seat comfort, okay, or it can be like shock absorber, so shock absorption. Then weight of the vehicle or the tire, okay, it can be the tire size or type. Okay, so a higher level function can be always break down into smaller functionalities, because multiple functional blocks may contribute towards a particular higher level function. So in order to achieve a higher level function, we check what are all different sub functions that actually we need to accomplish in order to achieve the higher functions. And based on these smaller sub functions, we then decide upon the elements, the mechanism, the circuits, and various parts that are required to achieve these particular higher functions. So this particular process is called functional decomposition. So figure here represent that what we did previously was customer need analysis. Then we come at particular specifications based on benchmarking, then arriving at various competitive values, and then ideal and marginal values. Then we did a quality function deployment to understand what are the functions or what are the specifications that are important to satisfy customer requirements. Okay, now we have a set of specifications. Within that set of specifications, we do functional analysis. That means we check among those specifications how many actually are functions, because rest are constraints. So we consider the functions and then we do a functional decomposition like this, and then we move forward for concept generation. So this is a standard practice in product design. When we arrive at a specification, then in order to move towards the concept generation phase, we do a functional decomposition stage. Okay, clear? Okay. Okay, so next question is how to do functional decomposition. Okay, so are there any standard systematic approach how we do functional decomposition, or we can just do it by without any means or any tool? Okay. uh, Actually in early days, like when these sort of questions come, like how to convert a particular function into product feature that is important in concept generation phase, most of the time experts are used to involve. So experts domain knowledge, okay, domain knowledge as well as their prior experience in uh, working on particular concepts actually matters. However, there are some sort of tools and techniques using which even novice designers also can then come up with certain product features and can do a perfect functional decomposition. Okay. So there are basically two types of methods. One is, some of them are simple methods, sorry it should be plural, and there are robust methods. So what are the difference? So both simple methods and robust methods, these are the basically of types of method, okay, for functional decomposition. The difference between these two are that the simple methods are actually much simple and easy to use for simple products, like that of a product like saver, or a product like juicer. Okay, the robust methods, which are a bit complex are useful for complex product like a motorcycle, because these actually comprise of it's like a chain of products. Like you can consider even a light set is a product. Okay, so these are like a sub products. Even a wheel you can consider a product. So a bike as a product, if you consider, is mostly as a assembly of various small products. However, a simple product having a small set of functionality can be easily uh, used using this sort of simple method of functional decompositions. So, in this lecture, I'll be covering the simple methods, which will be comprising of a method called SOP and FAST. So, I'll move forward. So, the goal of using simple method is arrive at something called a functional trees. Okay. So, basically, a functional tree is something where we uh, gather various functions and sub functions into a tree structure. Okay, we arrange the sub functions and sub functions in a hierarchical order. Okay, so this is the goal of a simple method like SOP and fast method. Okay, I'll explain in detail what are those things. And in robust method, we actually go for something like a structure. It's not a hierarchical model. It is much more complex, which we call as function structure. But in this course or in this particular class, I'll be covering these two topics. Okay. So have you gone through the course material of sixth week lecture videos?
Currently not.
Okay, because
Definitely.
okay, because tomorrow is a deadline for assignment submission, and I'm trying to cover some of the important concepts that will be useful for solving those assignments. Okay, so one of the very important concepts that you need to understand before solving the assignments is functional decomposition. Okay, so one of the simple method for functional decomposition is subtract and operate procedure. Okay, so what we do for simple products like as I told before, like simple product like electronic saver or something like a juicer. It's like product having single function, single basic function. So a function of a saver is primarily to save, right? So products having less complications and having minimum functional blocks can be easily decomposed, functionally decomposed using this particular technique, which is subtract and operate procedure. So what we do here is what we consider a prior product which already exists, and we then break down or do a we remove a small part of this particular product, and we then try to run this particular product and analyze the importance of this particular functionality, particular feature. Okay, so this generally are useful when we use a reverse engineering approach in product development. Okay, so in reverse engineering method, basically we generally try to understand something which is technically complex by dismantling a existing product. So for example, this is a saver, and what will happen if we remove this particular features. I will say features because imagine that you do not know, it's a new product for you, you do not know what are these particular sources. Probably a form factor, maybe not like a battery. So what will happen if you remove these particular units?
We will be getting different components arranged in a such a way that it functions, performs something that we require.
Okay, basically if we remove this particular battery, you will not the motor will not run. That means you will understand that this particular uh, you know feature, for example, if you say this is like a component C1, this is main source of power. Okay, so what we do next, for example, we cut this particular two wires. Okay, and then we try to see whether we can run this particular device or not. Then we'll understand that these are the key electrical wiring that actually supply from power from here to here, because without this particular thing will not work. So a component wise C2 will be at a transmission of, basically it's transmit electricity. Okay. Now next thing, like you can actually try remove this, which is like a plastic portion, and then you try running this product. You will get a motor rotation here. Okay, you will see the shaft is rotating, but but there is no transmission of this rotational motion into the cutting mechanism because there is a absence of this particular feature. So you will know this particular feature, component or feature C3 is actually, it's a converting the rotational motion into a cutting action. So in this approach, what we do is like we dismantle a product, existing product, and we try to isolate the smallest isolatable function or feature, and then we try to analyze the rest of the functionalities, and we do it repeatedly. Okay, we
Yeah.
this one by one, and every time we analyze a particular function, then you again fix that particular feature and you try analyzing other parts. So slowly we understand that all the various features or components available in this particular product. So next what we do, we then try to understand, okay, how many there are different features or components within this particular product. So probably C1 to C10 are the components. Okay, then these
Mhm.
components we try to break down into functions, like which particular component is actually performing which particular function. For example, C1 is a battery, so it is like a sourcing power. Okay, then electrical is like C2 is basically transferring electricity. Then probably there is some sort of motor here which is hidden, so then C8 probably is a motor. But what is the function of that? The component is C8, which is a motor. The function is it's convert electrical energy to rotational energy. Then we have this particular component C3, which is like a converting a rotational mechanism into a cutting mechanism. Then we have the cutting blades at the end. So likewise, we actually identify various small functions, and then we create this functional tree. So how we do that? We come from bottom to up. So we, for example, so wait, someone had joined. Okay. So what we do here, we basically first try to draw the smallest functionality. For example, we understood that the cutting mechanism, when we remove this particular cutting mechanism, it does not affect anything else, it only affect the final cutting part. Okay, then we realize that when we actually remove the particular shaft or this particular portion, we realize that this removing this particular component like the C3, which is convert rotational to cutting, this particular function, when you remove this, both of these functionalities does not work. That means you understand the hierarchy wise, this is above this particular functionality, which is cutting blade. So likewise, when you actually next you remove the motor, you understand that by removing the motor, both these functionalities are not working. Okay, so by doing this, slowly you reach the top, and then you get the basic top level, higher level functionality, which is saving, basically saving tool. Okay, saving. So for saving, then you create this particular tree, which are which will be generated in a reverse order. You first start from the very after detail analyzing all the features, you try creating this particular tree from bottom to top. Okay, so am I clear? Any doubt?
Yes, sir. Clear.
Okay. Okay, so tell me, what are the limitation of this particular technique?
Once you remove all the connection, or you starting decomposing it, you might lose the main functionality also. Actually, if you cut directly the wire, which maybe performing two actions, or you can't use that product again. If you cut the wires and uh, uh, something destructive you have done, other unless just removing things.
So let me give some insights. So very first thing that we are assuming in this particular process is like, whenever we remove something, we will realize some sort of feedback, whether positive or negative we don't know, but we assume that if we remove this particular thing, something will not work. Okay, or the product will work differently. However, for example, if you remove this here, this is not going to work, because there is only one there's a linear relationship between various functionalities. Okay, sometimes in certain products there can be multiple dependencies. Okay, the particular functionality may have different input functional dependencies. So that means when you remove a particular function, we may not realize the exact outcome, what is the use of this particular feature, because we what we are observing is a cumulative observation from three different smaller sub functions. Okay, understood? Am I clear this one? Okay, let me explain it again. For example, imagine uh, there is another particular element. For example, this is not only saving, there is something more like adjusting, something adjusting the height of cutting. Okay, there's some mechanism that is a feature which, when you remove, actually you know that now you cannot adjust. Okay, however, if you are a newbie and you do not know like what is this particular component, it's a new product for you. Even after removing this particular product, there is no such change you may feel visually or in terms of mechanisms. So this particular feature, you will feel that this is redundant, some sort of redundant feature or some sort of redundant function. So these are some of the limitations of this particular method, because it depends highly on observations. Like whenever some things get removed, there should be some sort of feedback or some sort of different functionalities. That is one. Second thing is like, This way of product development is that means that there should be always something there, already existing product. You cannot use this particular approach for new product design. That means, you know cannot be used for new product design. Why? Because you do not know actually what are the various components that are necessary in a new product design. So this is not useful in new product designs. uh, Another are like, no, this is mostly used for reverse engineering methods, and which is sometimes not ethical. And even if you do it, there is no guarantee that you will be your a designer's mental model already get blocked by what actually already exists as a product. So these are some of the limitations of this particular technique of functional decomposition. Clear?
Sir, yes, sir. Sir, may I ask a question which is out of syllabus?
Yes.
What is the scope of reverse engineering in India? Are we actually more towards the reverse engineering, or towards new product development? If we say overall over the from the career perspective, so what is the chances for a reverse engineer, design engineer, or a new product design engineer?
Okay, so reverse engineering, do not think it from a negative perspective. Reverse engineering is a standard practice, in engineering, where actually we try to explore. There are a lot of different reasons why we do reverse engineering. Sometimes we do when we try to explore unknown technology. Okay. Now this is there are ethical issues come when actually there are some sort of IP conflict. Okay. However, there are other scopes of reverse engineering. For example, your product failed. Some product failed in the market. For example, you know that Apple 6 when initially came, there are some issues like the phone get curved when you put it in a pocket. Okay, so initial models of Apple 6 iPhone, they face this particular issue. There are a lot of reports. So what you can do, like what companies did is like they actually bought Apple iPhone, then they try to analyze why it bends, and they then identified it is basically the body was aluminum, and there are a lot of cutting side cuts which actually minimize the strength of the material in this particular axis. Because of that, whenever it is in pocket it gets bent. So this is where actually we try to understand a particular limitation, and then we come up with a product which is a better product. So sometimes to improvise bad products, you do reverse engineering. Okay. So scope of reverse engineering in India is like, reverse engineering always have scopes. New product design is always good. Okay. However, you need to think about the customer base, that you are going to target. So if you are a startup company, so you have a commercial goal. If you are a company, you have a commercial goal. So jumping into a new product design probably
Yeah.
will be a issue for you. Probably the customer may not know a new product. Okay. However, in a different way, this can be a niche area. Okay. So this can be a new value
Yeah.
propositions. Okay, so you need to take this particular call, very precisely, very smartly. uh,
Yes. Sir, actually, I want to know. Actually, earlier I used to work in a company where what they used to do, that actually in India the manufacturing of medical devices is very less. So we have renowned names of companies who are famous all over the world for medical devices. They used to do there. We used to do what? Take their product and disassemble them all the parts, and yes, see slight differences what we can do, and yes, but at the end we came up with that same product, but
mhm.
you can say that that's an Indian product. So is that uh, feasible, or is that unethical or ethical?
So unethical if IP, there is IP involved, intellectual property involved. That means IP means patent. Okay, someone's copyright. If you are violating someone's patent, copyright, hard work, because then that is illegal. That is unethical. For example, China stole the aircraft architecture from US unethically by hacking the server for their J-20 stealth aircraft, which is unethical. However, is something like not patentable, like already the patent expires. For example, patent is 20 years period. Okay, so for example, a medical device which was first patented in 1990, its patent expires in 2010. Okay, after 2010, if you do reverse engineering, because you do not know this particular technology, you do this particular reverse engineering to understand the underlying functionality, to do this particular functional decomposition, and then you arrive at either a improved product or a similar version of the product. This is not non-ethic. It's not, no, it's not, there is no issue with ethics, because the patent law says like any invention that actually beyond 20 years, this is meant for free public use. Okay, the inventor get a 20 years of exclusive licensing or exclusive right to sell this particular product. Within these 20 years, if you try to do reverse engineering, or you can do reverse engineering, but if you try to make it commercialized, then actually you are actually violating the IP laws. So that is not ethical. Clear?
Sir, are the patent laws in India are more free in terms of Western countries? Because the company where I used to work, the renowned companies of the world, they also used to visit us, and they know, yeah, yes, they are making the copy of our own products, but they haven't took any action. I don't know why, but if we were doing some unethical thing there, then why they haven't took any action? Are they are more flexible rules in India, or something else?
So for that, actually, you need to make sure, like, probably there are, sometimes it is a strategy for various manufacturers that, they try to market their products and they do not have any issue. Okay. So, or maybe you are exploring some of the important, some of the functionalities which are not IP related, which are not protected by themselves also. So this happens. For example,
Definitely.
Microsoft does not care about IP for their products, because they want the Windows system. So for example, Windows. So they actually want that people use Windows machine. So they do not care about if you have a illegal copy of MS Word. These are some of the strategies. It's like you have
Okay.
a, as a student, you get a student version of SolidWorks. Okay.
Yes, sir.
Okay, that means what, that company wants you that when actually you get into your professional level in the industry,
Yes.
then actually you demand a SolidWorks, proper
Mhm.
license, so the company get dependent upon you and your product, the software. That's why they give a free license to the students. So these are strategies for future marketing.
Okay.
Got it? Okay, anyway, that was out of
Okay,
the
sir.
topic. Okay,
Yes.
let's finish this particular next topic, which is functional analysis, and the fast technique, which is functional analysis and system technique. So in this particular technique, we generally do it for new product design. So the earlier one, which we are talking about, the subtract and operate procedure, this was when we actually have a already existing product and we dissect it and try to identify various features and functions. The other method is function analysis system technique. Is a it's used for functional decomposition for new product designs. So what we do here, as a task, we create two vertical lines, and we actually do from this side, like we write down the output, the higher order output functions. So what we think is the functionality of a this particular juicer or grinder. So for example, its output
Sorry.
is
The main function of a, yes.
Okay, it's like you can make some masala. Okay, some masala
Yes.
grind. Okay, or juice grind or anything. So this is what the output you demand, and as an input, as a layman, people may not have a proper knowledge. People may think, okay, because I am giving electricity,
Yes.
this particular thing is grinding. Okay, now
Yeah.
this electricity is a assumed functions. It's not like a someone like an engineer derive this particular
Yes.
input. This is someone like a layman, like it's like why the bike is running, because there is petrol. It is as simple as like that. So here is also like that.
Yes.
When you say why this particular masala grinder is actually grinding masala, because you are providing electricity. So this is something that assume functions or the input.
Yes.
Okay. So what we do next is like we come from this side. Okay, and we ask the simple questions like how. So when we move from here, we ask the question how. So how to grind.
Okay.
Okay, we ask how to grind. So we say like by rotating blades, like chopping with or grinding with blades. Okay, so this is like the we are trying to do some sort of understanding or going to the sub functionalities from the higher order functions. Okay, so this is very different from the other method, where actually we try to get the particular function tree from bottom up. We try to create the functional dependencies from bottom to the top, because here we do a reverse engineering and we try to map, like if we remove this particular, what are the various features gone, like if we remove this, what are various features gone. To understand that, a top down approach will not help, because if we remove the battery or the basic feature, nothing will work. So we'll not know the hierarchy of functions here. However, for new product design, we do this particular approach, where we ask like how this particular masala, how masalas can be grind. Okay, then you say, look, chopping or grinding using blades. Okay,
Yes, sir.
now next questions come again. You ask how. So you ask how multiple times. You said how grinding, with chopping. You say that, okay, you rotate the blades. You understand? Here we say
Yes, sir.
grind with blades, we say rotate the blades. Next, ask again how rotate. Okay, how rotate means you need something that actually rotate the blades. That means you are converting the electrical energy into the rotary motion. So convert electrical energy to rotary motion.
Mechanical.
Okay, so this is one. Similarly, if you ask like how to convert, rotary, like electrical energy,
Yes.
then you ask like you need this particular mechanism along with the required electricity. So then you need to go down to e electrical energy conversion, okay, to magnetic field. That's how motor work, magnetic field. So this is how actually you ask the question how to perform a particular function, and then you actually get to know the sub function, and then you actually end up connecting the assumed function, the very basic input that we think about. Okay, okay, so part this particular part of functional mapping is called critical path function. Okay, so next what you do, for every critical functions, you then try to analyze the detailed functional requirements. For example, chop the grind with blades. Okay, but before chopping and grinding, you need to, collect the vegetables, collect the masala. Okay, okay. So then what? So if you collecting masala, that means it should store masala. So these are like, the sub functions of these critical part functions. Similarly, for rotating blades, there can be no sub functions like the blade should be removable, because for different spices or different food products, you need to change. It should be able to change the blade. So change blade. That means the blade needs to be changed. It can be a fixed blade. Okay, then it can be like washable blade. So all these functionalities which actually come under these particular critical functions are called sub functions.
Okay.
So when you map at the end, like for example, I'll quickly finish this. Like for example, converting E to rotary motion. So that means you need now you need to think about the motor. So you need a power. So motor power requirement can be a function. Okay, that's a particular way actually how you need to write a particular function. The way you need to write a particular function is a verb plus a noun, or the opposite. Okay, for example, uh, it can be grind masala, but that is not a constraint. Like you can use different language also, but this is like something easy to analyze and in the later stages. So when you say grind masala, okay, it is a function, one verb, one noun. So like collect masala, so verb noun. So store masala. Okay, for example, this is what change blade. So this is how you actually uh, you know uh, write down the functionalities. Like power requirement is not a functionality. You say you know uh, provide you know power or torque, because you need torque. Okay, similarly, there can be other sub functions. E conversions can be like constant voltage. Okay, so constant voltage again var when these things. So this will prevent from electrical damage. So when you actually later do these sort of secondary mapping of sub functions, you will end up actually generating the overall functionalities of a particular product. So then you can actually map it like, first we will provide electricity. Okay, then you ask a reverse questions to try to validate that your findings are right. Now you ask a reverse question like, why you need electricity. Okay, earlier you go from the
Hmm.
left side, you ask like how you do that. Now you ask why electricity. Now you say why electricity, because
Hmm.
electricity needs to be converted into magnetic field. Okay, and
Okay.
electricity needs to be what is that, constant. It should be constant voltage so that there is no damage to the device. Okay, then you go
Yes.
ask why electrical conversion. Okay, now ask you why. This is for validation. You say okay, electrical conversion is required because now we want to convert electrical energy to rotary motion. Okay, then again ask why. So why electrical energy? Because with the electrical energy we are trying to rotate the blades. Okay, and then why rotating blades? Because we are trying to grind the uh, particular masala, or no, we want to chop and grind. Then why? Because we want to get a masala mixture in the final higher order function. Within this we can again ask why we need a masala, or to collect the masala, because we need to chop this. Then why need to store? So likewise, like you store, then you collect, then you do this. So you can ask why multiple times to validate that your functional decomposition is actually right. Okay. So this is
So
how.
this is this a why analysis is same as why analysis that we use in a quality problem root cause analysis? Why to get to the root point of the problem.
That also we do there also, even if you requirement analysis, when you try to understand the root cause, we ask why. But you know what happens, like when you in go to a root cause, see the difference is like in a root cause the problem is same, but we are trying to understand a one level down. Okay, one level down. For example, if you say very similar, but you know the purpose remain the same, the context remain the same. For example, if you say someone yesterday, day before yesterday, Cyrus Mystery died. Like you ask why died? Why died? Because of road accident. Okay. Ask why road accident? Then you say like because of slippery roads. Then why slippery roads? Because of rain. So now you want to get to the problem. Okay. So this particular thing actually try to understand the root cause of a problem. But here what happened, like contexts are different. There's a dependency from one event to the other. These two are not the same event. Okay, you can say the vertical sub functions probably is the functional decomposition of the vertical sub function is probably similar to your this root cause problem identifications. So within this particular functional critical function part, you then try to understand the sub functions. So this is like a probably a why to a underneath sub functions. So this is similar, but this is not similar. Okay, so what happened, like when we do a functional analysis, so we have some sort of primary objectives. So this first level, which is actually the we have a higher order function, right? Anytime whenever you work in a product based industry, we are given in a project like, okay, make a mixer which can grind masala. Okay, now this is like a aim, but then you break down the particular aim to certain objectives. Okay, so this first set of vertical, this first vertical set of these things are actually your project objectives. Okay, and there are certain one-time functions which also come within this network of product functions. For example, what are one-time functions? It can be like of packaging, like first time packaging and distribution. So it's like one-time function. So you need to provide a good cushioning on the package. We need to provide thermocols. So those sort of maybe, and it's not come here because your objective is also just to masala grind. There can be another parallel primary objective which can be like you know easy to transport. Then those can be one-time function. Similarly, there are all-time functions. Okay, what are all-time functions? You know like easy to store the product, easy to grind, efficiency of grinding. So all these are like all-time functions. You always want this functionality to be maintained. Again, there are certain unwanted functions. So you try to solve a particular problem of masala grinding, but you end up having certain functional outcome which actually are not intended. For example, because of your motor, noise level increases. So now you want to have a filter, some sort of noise filter or noise masking functionalities in order to reduce the noise, which are actually unwanted functions. It actually increase the cost or the time. Okay, like noise filter. Got it? Okay, so this is
Yeah.
how actually we do functional analysis and analysis system technique. And after doing this, we then go for uh, developing the functional tree. So functional tree is basically nothing but a representation of this uh, various functionalities in a hierarchical order. So here there is no hierarchy. we just try to understand from left to right how we can and derive a particular higher level functionality from a lower level functions. However, when we map it in a particular tree structure, we have a better understanding, like what are the main objectives we need to fulfill, what are the sub design elements, what are the sub functionalities, and this will better help a designer to arrive at a functional design at the conceptual level. Okay, so for example, these can be one of these critical function part. This like critical function part 1. This can be another critical function part 2. So critical function part 3. So what happened here, I just explained one particular critical analysis, like critical function path, which is the objective is to grind masala, higher order functions. However, if you see, when you are designing a particular masala, or for example a particular grinder, now you may have multiple objectives, like for example you want to chop food items. Okay, that is one goal. It can be having like you want to make juices out of it. Then you there can be like there should be some provision to store the food. If you try to think about something like a food processor, and there you can actually store the food for a certain amount of time without spoiling. So those features someone can think about within a mixer grinder. So because these are some of the entirely different basic functions, that's the reason why you need to go to the sub functions as different critical function parts. For example, chop, grind, so then rotate blades, convert electrical energy to torque, then supply appropriate electricity. For making juice, it can be like citrus fruit. So citrus fruit, you need to squeeze the citrus fruit. For a non-citrus fruit, you need to grind it. So now you need to think about mechanisms to convert electrical energy to squeezing mechanism. Then for non-citrus, you need to think about electrical energy to grinding mechanisms. Okay, and at the base level, all the inputs are same, like what we call as assumed input. Similarly, for storing, we think like okay, there should be airtight lid, and then we say like maintain the temperature so that doesn't get spoiled, then use appropriate material so that it doesn't get spoiled because of the material properties. So the basic functionalities, like at the very level 1 we have the basic functionalities. Then at other levels like level 2, level 3, we break down the basic functionalities into secondary functionalities, which may have multiple levels of decomposition. Got it?
Yes, sir.
Okay, any question?
No, sir. Thank you.
Okay, so that's the end of today's session. Okay, so I covered in this session, in the last class, I discussed about how we can arrive at specifications using various techniques, and in this class, I covered how these specifications are actually converted into functions using two functional decomposition method. One is the SOP method, which actually generally used in existing products using reverse engineering. The other one is this fast method, which actually used for non like new product design, and they are actually we at the end generate functional trees. For both the techniques, we generate functional tree at the end. Okay, and this is where actually from here actually we go forward for conceptual design. Okay.
Okay.
Okay. So
Okay.
thank you.
So first, yes, thank you. Thank you.
Any question?
No, sir, actually, just I was saying that first we develop a functional tree, functional diagram, then we move towards the conceptual. So next week will be the conceptual design phase, right?
Yes, yes.
Okay. Okay. Thank
Okay.
you.
So please come to the class early. Next class will be again next Tuesday 6, from 6 p.m. So those I know understand, like some of you have might have no office hours, and if you actually have office hours, then try to attend these particular classes in the office, in office place itself, or make sure that you attend these classes because these are important. And the course which you are actually taking in this semester actually is not a live running course. I'm the only person who is actually taking these live sessions. Other than that, the rest of the course materials are actually available in YouTube. So there is no direct interactions which actually can guide you or help you in understanding the core concepts. So tomorrow is a deadline for your assignment submission for sixth week. So today's in the today's session, I covered some of the important concepts which actually help you in solving those assignments. And deadline is tomorrow at 11:59 p.m. So please make sure you solve the assignments.
Yes,
Okay.
yes, surely. I will do.
Okay. Thank you, and please be present in the next class also. Thank you.
Yes, sir, surely. Thank you.